Hey folks, welcome to this episode on drawing covalent structures. In this episode, we're going to be looking at HCN and trying to draw this covalent molecule. First step is trying to figure out how many electrons each of these atoms are coming into the structure with. So we have H, C, and N. We have one of each of these, so we'll put 1, 1, 1. And now we have to look at what group they are in. Hydrogen is in group 1, so it has 1 valence electron. Carbon is in group 4, it has 4 valence electrons. And nitrogen is in group 5, it has 5 valence electrons. So in this case, we'll go multiply these through, we'll get 1, 4, and 5. And if we add these up together, we will have 10 electrons. Second step is to figure out how many they would need to have a full outer shell. Hydrogen, carbon, nitrogen. Again, we have one of these, and one of these. Hydrogen only needs 2 electrons to have a full outer shell, while carbon and nitrogen both need 8. And so multiplying this through, we will have 18 electrons. So they need 18 electrons, they only have 10 electrons. Let's see how many they need to share to create those bonds. So we'll take 18 minus 10, and we'll get 8. They share in pairs, so divide by 2, and we will have 4 sticks. Now, that's kind of weird because we only have a central atom, which will probably be carbon because it has the most unpaired electrons, and then we have 2 terminal atoms, the hydrogen and nitrogen. So technically, we would really only need 2 sticks, but we have 4. So that means we probably will have a multiple bond, like a double or a triple bond. Fourth step is to see how many electrons, if any, we have remaining. So we'll take what we had originally, 10 electrons, minus the 8 that we've used for sharing or bonding. That leaves us 2. And again, lone pairs come in pairs, so we divide by 2, and we will have 1 lone pair. All right, so knowing this, we are going to put the atom that has the most unpaired electrons into the center. Carbon is in group 4. It has 4 unpaired electrons. Nitrogen has 3 unpaired electrons, and then hydrogen only has 1. It will never be a central atom. Carbon is going to go in the center, flanked by hydrogen and nitrogen. Again, treat this area around carbon as a 360-degree circle. And so the farthest that hydrogen and nitrogen can get away from each other is going to be 180 degrees, right? So if we took 360 divided by 2 atoms, we get 180. We are going to place these atoms on opposites of one another. We'll put the hydrogen here, and we'll put the nitrogen here. Now, if you look at this structure and you look at the formula, HCN, you can see there's a resemblance. And in many cases, not all cases, but in many cases, the formula might give you clues to the actual structure. We call these structural equations. There are also equations called condensed equations where they just condense all the atoms, or they put the similar atoms together and they don't really give a hint of structure. In this case, that's not it, because we really don't have more than one. Now, without looking at how many sticks we have, we're just going to attach these terminal atoms to the central atom, and we've used 2 sticks. But again, we have 4. Knowing that hydrogen can only make 1 bond, it only has 1 unpaired electron, and nitrogen can make 3 bonds, what we're going to do is we're going to place these sticks between carbon and nitrogen, and we'll actually make a triple bond. So this is an example of using these sticks, these quote-unquote sticks, to create a multiple bond. We have used 3 sticks to make a triple bond and a single stick to make a single bond. We've used that. Now, we have 1 lone pair, and we have to figure out where we're going to place this. Each one of these sticks represent 2 electrons. So hydrogen has 2 electrons shared beside it. So it is actually good. It only needs 2. Perfect. When we look at carbon, carbon is also sharing these 2 electrons here, and it also has 4, 6, and 8 beside it in this case. So carbon is also good. Okay, so carbon and hydrogen, we've seen that they are good. When we look at nitrogen, nitrogen has the 2, 4, and 6, these 3 different sticks, and it needs 8. So this is the atom that we're going to place the lone pairs with, and we'll place them off to the side like this. Remember that these lone pairs are negative, and these bonds over here are also negative. And so negative and negative, the law of electric charges tells that they repel, and this is why we usually put them onto the other side. They would be far away as possible. Now, with everything having a full outer shell, we are done our structure. We have no charge, and this is our final structure of HCN. Hopefully you found this helpful. Thanks for tuning in, and tune in again to see more examples of other structures.